Okay, good evening, ladies and gentlemen. This is Professor David J. My topic for tonight will be how to set up the exhaust fan of my old microwave oven, which is over the range. I disassembled the microwave oven, and I got the parts which I will be using for my benefit. So actually, I bring out the exhaust fan. The exhaust fan is this one. This is an exhaust fan of a microwave oven over the range. This is where the smoke or air coming from inside. That's the intake. And when this rotates like this, it will suck the smoke over here and it will bring out here. So if this is connected to a duct going outside, this works as an exhaust fan. But actually, we could use this one independently. If we got so much smoke in our kitchen, we could open our window and place this one over near the window. Okay, then you try to plug in this one, so this will try to operate independently without the microwave, of course. So any smoke that's coming out from the kitchen, it will be sucked over here. First one. The second one is actually on the other side. So there are actually two suction points. First one, the other side is the second one. And these are the exhaust fans. The left and the right. And this is the core. For a microwave oven over the range, the exhaust fan got actually a capacitor. So this is the capacitor. The rating is 10 microfarad, 220 volts. This one here, the terminal here is in parallel with the terminal of the, what they call this, motors. Okay, they're in parallel. So when we try to energize the motor, okay, the capacitor will try to initiate the rotation because sometimes the motor got a little friction. So for it to operate initially at a good speed, we must have to use this capacitor here. Okay. So this one is in parallel with the winding of the motor, in parallel with this, because this end terminal here represents the winding of the motor, right? So they are in parallel. So it's just like a capacitor is actually a power booster. And I tried to measure the resistance across the terminals because I would like to take note of this one. For the exhaust fan, the resistance between line 1 and number 2 for this one is actually 29.2 ohms. That's actually the resistance of both the first and the second. And they are in parallel with the capacitor. So when we try to energize, like what I said, capacitor is actually a power booster, you know. It will try to initiate the rotation of the motor because there are some inertia at the start. So for it to operate instantaneously with a good speed, we must have to use this capacitor here. So actually, this is the exhaust fan. Resistance between line number 1 and line number 2, I use my multimeter, 29.2 ohms. The specification of the capacitor is actually 10 microfarad, 220 volts. Okay, it should be connected in parallel with the resistance of the two exhaust fans. Okay. So the use of the capacitor is just actually a power booster. Okay. There are some inertia or drag force at the start. So to momentarily overdue that inertia, we must have to use this capacitor here for the exhaust fans to operate instantaneously in a good speed. Okay. So these are the outlet going to the duct. This one. First one, second one. So if you try to connect this one to the duct going outside, and you try to operate this one, any smoke from your house will be diverted to the duct, like what I said, right? But for me to use this one, I will just place this one near a window, maybe near a window, open window. Okay. This is the inlet of the smoke that's generated in the kitchen, and so with this one. So if I try to plug in, okay, the smoke will be what I call the suck over here. The electric fans or the fans will try to operate. It will bring out the smoke that's generated from inside the kitchen. Okay. So I don't need a duct for this one to operate. I will just place near this one near an open window. And if there is a smoke generated inside during the cooking time, or the smell maybe, I try to plug in this one. The smell and the smoke will be sucked over here. The fan will operate. It will bring out this one, going out on the window. So if we try to operate this one now, okay, this is the power supply. I did this a while ago. I didn't show you the actual performance of this one, but if you try to see it, this is done in a good manner, right? This is the terminal of the capacitor. It was soldered over here, and this two terminal is in parallel with the resistance of the two fan motors. And the power source of the two fan motors is actually this white and black line here, and actually it corresponds to this first one and second one. This ground here is material now because there's no grounding thing here. But I don't want to remove the grounding thing. It doesn't matter. There's no ground over here. We only need two lines here. Okay. So if we try to see the performance of this one, okay, it is something like that. Like what I said, this is where the smoke or the smell will be coming in. The pan will operate. Okay, so it will be blown over here. So if this opening here is near a window, of course, the smell and the smoke generated from the kitchen will be diverted to the open window. Okay, I will try to plug in this one now. Okay, the convenience outlet is not switched on. So if I would like to show you if this really operates, we'll try to see. I will try to plug in now or switch on the switch. And as you could see, okay, this is very strong. Right? Very strong. This is the inlet for the smoke or the smell generated on the kitchen. Okay? As you could hear it, it's very powerful. Okay? It's very powerful. So, from my old microwave oven component, I brought out this one because I could still use this one as a exposed one independently. Okay? This will go out on the window. Okay? So if you are cooking, heat is generated or smell is generated in the kitchen, you can bring it out by using this one. This is actually the one being used for microwave oven with the specification over the range. Okay, it works. Very strong. Good evening from Los Angeles. This is Professor J. De Los Rios.